Okay, hi, this is Miss Triangle. This is the video for section 2.5, which is basically on two-column proofs. In your textbook, Big Ideas, it's called proving statements. So please make sure that you're putting the date and the title and topic 2.5 proving statements in the top right. Make sure you're setting up your lines for your Cornell notes and that you're writing your essential question, your EQ, what is a proof and how do you write a proof? Learning target, we're on 2E. I can write a two-column proof about segments or angles. So if you need to pause the video, go ahead and do so. All right, so what is a proof? A proof, let me zoom in a little. So what is a proof? A proof is a logical argument that uses deductive reasoning. So you're using like known facts and postulates and theorems to prove that a statement is true. Two-column proof is a specific type of proof. It's a T-chart with two columns. The column on the left is called statements, and the column on the right is called reasons or explanations. And we will be writing several two-column proofs, so you will see what a two-column proof looks like. Okay, our last vocabulary word is a theorem. A theorem is a statement that can be proven. Once you've proven a theorem, you can use it as a reason in other proofs. That word got cut off. So if you need more time to copy down the vocab, go ahead and pause the video. Otherwise, I'm going to keep moving. All right, so here for theorems, Theorems 2.1 and Theorems 2.2 are pretty similar, so you don't necessarily need to write them twice. You should have something written for reflexive, symmetric, and transitive. You don't necessarily need to write it twice. It's in here twice because one talks about line segments and one talks about angles. But they're really similar, so I don't think you need to write it twice. So there should be something written for reflexive, symmetric, and transitive because those are properties you're going to use in your proofs. All right, so reflexive. Reflexive is basically saying anything is equal to itself. So line segment AB is equal to line segment AB. 5 is equal to 5. Angle A equals angle A. So reflexive means it's equal to itself. Like you're looking in the mirror, you see your own reflection, it's the same person. Symmetric. Symmetric is basically the order changes. So it's kind of like the commutative property in algebra. So 3 plus 4 is 7, and that is equal to 4 plus 3. Okay, that's what the symmetric property is. You can change the order. All right, and the last one is transitive. So transitive is basically saying if AB is congruent to CD and CD is congruent to EF, then AB is also congruent to EF. Okay, so summarize, you need something written for reflexive, symmetric, transitive. You don't need every word in this copied down. All right, example problems. If your hand's tired, you can just put EX. All right, you do want to set up the problem, so pause the video, write a two-column proof for the situation in example 4 from section 2.4. So if you're thinking this problem looks familiar, it is. We're going to do a two-column proof. We did an algebraic proof, a three-column proof last section, so we'll be solving the same problem. That way you're familiar with the problem, but you're getting a chance to see the new format of a proof. All right, so I'm going to go ahead and set up my T-chart. So I'm going to put statements, and if you want to put S, that's fine. And reasons. If you want to put R, that's also fine. So remember in lesson 2.4, I always told you to start with what is given. Same thing in a two-column proof. So your first line, no one should ever hand in a blank proof on a quiz or something because you know what the first line should be. Measure of angle 1 equals measure of angle 3. Why? That is given. Okay, now our goal is to prove that DBA, so we want to prove that that angle, this big angle here, is congruent to EBC. Okay, so that is our goal. All right, so let's start with DBA, which is our goal over here. Okay, so the measure of DBA, how can we describe DBA? So DBA, I'll make it red here. DBA is basically the sum of angle 2 and angle 3. Okay, what's the reason? That's the angle addition postulate. When you add two angles. So you may like the 2-column proof because there's only 2 columns instead of 3. Then let's see if we can sort of write this another way. So I'm still talking about DBA, that big angle in red. Now instead of saying that it's angle 2 plus 3, what I'm going to do is, because angle 3, highlight this for you, angle 3 is equal to angle 1, because that's given to us, I'm going to go ahead and change that. So I'm going to say it's equal to angle 2 plus angle 1. So I'm basically substituting angle 1 in place of angle 3, because from line 1, from what was given to us, they're equal. They're equal. So that is substitution property of equality. I'm just going to call it substitution property. Okay. Now let's talk about the other side. The other side. So that would be EBC. EBC is equal to angle 1 plus angle 2. And that is also your angle addition postulate. All right, now let's look at what we have here. Do a different color. Okay, so here I have angle 1 and angle 2 is equal to EBC, and here I have angle 1 and angle 2 is equal to DBA. So if DBA equals angle 1 plus angle 2, and EBC equals angle 1 plus angle 2, then I can go ahead and say the measure of DBA is equal to the measure of EBC. And what property did we use? That is the transitive property. Okay, so pause the video if you need to. I know that I'm done with my proof because the last line should always be what it's asking you to prove. Okay? All right, question 2. So you are going to copy this down and fill out the chart. This is probably what you'll see more so on a quiz, is like a fill in the blank. There may be one question where you create your own proof, but some of them will be fill in the blank to kind of guide you along the way. So pause the video, set this up. 6 steps of a 2-column proof are shown. Copy and complete the proof. Given that T, so here's T is the midpoint of SU. Prove X equals 5. Okay, so the first statement says T is the midpoint of SU. Right here, T is the midpoint, T is the midpoint. What's our reason? That should be given. That's always your first line. Okay. All right, what do we have next? ST is right here. ST is congruent to TU. How do we know that? That's the definition of a midpoint. Definition of a midpoint. Okay. ST equals TU, definition of congruent segments. All right, then we're just substituting, hint, hint, instead of saying st, we're saying 7x. Instead of saying tu, we're saying 3x plus u. So we are substituting the algebraic expressions instead of the name of the segment. Okay. Then think about what would you do to solve this equation. So hopefully your first step would be to subtract 3x. And it kind of gives you a hint over here too. It says subtraction property. So 7x minus 3x equals 3x plus 20 minus 3x. And then what does that give me? I think they kind of skipped a line here. I get 4x equals 20, right? If I minus the 7x minus 3x on this side, gives me 4x. On the other side, the 3x and negative 3x become a 0, so I get a 20. Then what are they doing to go from 4x equals 20 to x equals 5? They're dividing by 4, so that is your division property of equality. Okay. So this is sort of the type, hopefully you could follow along with it for today. This would be the type of thing that we would expect you to be able to do